Hello everyone. Today we are going to learn 3.1 Euler's method. All right. Okay. So we have the format differential equation, right? So y prime equal to the function notation in terms of x and y, right? Then we have initial condition, initial value y of x naught equal to y naught. Yeah, just initially, right? So we using not there. We read, right? Okay. So when do we use the Euler's method, right? So if we cannot solve this differential equation, then we can use Euler's method to get the solutions. Yeah. Okay. So look, if we have actual solutions by the graph, right? Then Euler's method, we have x and y. Then x of 0 there, x of 1, x of 2, x of 3, x of 4, and so on until x of n. Yeah, just a subscription, right? Difference between in x, we called delta x, right? Then this will be step size. So we can make this notation step size, which is h. All right, then the height will be the y value, right? So we have y not there, y sub 1, y sub 2, y sub 3, y sub 4, y sub 5, until y sub n. We do approximation. So if we have a smaller step size, we can have better approximation. So let's take a look at this one. We have a y prime, which is a differential equation. So we have a derivative, right? So there will be slope of tangent line. Right? And then we have the function. Okay, now from the algebra course, we have a point slope formula, right? So that is y sub 1 minus y sub 0 equal to slope x minus x naught, right? All right. Then difference between x and x sub 0, x naught, we can say the step size, which is h. So we denote m times h. All right. Then look, we say that y prime is a slope of a tangent line. And then other side, we have the function in terms of x and y, right? So f of x and y, then say slope equal to m, right? Okay, then this m replaced by f of x naught and y naught. And then just rewriting what, I'm sorry, h here. Make sense to you? Yeah, I just did not want to writing out, but yeah, let me highlight. So m replaced by that, right? Because we say that f of x and y, which is say slope, which is m, right? Makes sense. Okay, then next one, y sub 2 will be y sub 1 plus h, which is the difference in x, which is a step size. Yeah. And we are using f of x sub 1, y sub 1, right? And then next one will be y sub 3 equal to y sub 2 plus h, f of x sub 2, y sub 2, right? Okay, next one will be y sub 4 equal to y sub 3 plus h, f of x sub 3, y sub 3, right? Now we can do more, right? All right, so we derive the Euler's method. So look, y sub n equal to 1 less subscription n minus 1, and keep that step size h, then f of, we're using the first term of the subscription x sub n minus 1 and y sub n minus 1. Yeah. All right. So let's take a look. Euler's method is based on assumption that the tangent line to the integral curve. So we talk about the integral curve in the beginning, right? Around 1.2 about the solution, right? Yeah, integral curve of at the point, then approximate the integral curve over the interval. Then look, so we had y sub n and so on, this one, right? So same as here, right? Same as here. Yeah. Or we can express just using I plus 1, the I is between 0 and n minus 1. So if we plug in n minus 1 here, then we get the same answer like this. Is it clear for you? Okay. All right, then let us do example so we understand how to apply the Euler's method. Yeah. Okay. So we have use Euler's method to use step size h equal to 0.1 to find approximate values. And then differential equation is given. All right. Okay. So with the initial value, right? So y of 0 equal to 1 means 0 is x naught, 1 is y naught, right? So x naught, y naught equal to 0 and 1. It's order pair expression, right? Okay. And this time, since the step size is 0.1, look, x equal to x sub 1 equal to 0.1. X sub 2 equal to 0.2, so increase by 0.1, right? Because the step size is 0.1. Make sense to you? That's how they got it, right? Yeah. But then we want to find only 3 steps. 1, 2, 3. Yeah? It's given. And then differential equation is like that. So the form of, look, we had earlier. The form is f prime equal to the function, right? That form. So we make one side just a differential equation form y prime and other side about the function. Make sense? Okay, so let's do it. So if we want to make a left side y prime, then left side negative 2y, both sides, right? So we have y prime equal to x to the third power e to the negative 2x minus 2x. This one, the right side will be f of xy. Is it clear? Okay, now let's do it. So we had the formula, this formula, right? We need to apply. Come on. Yeah. So let me make, right? Euler's method, yeah. Okay, so just leave like that. All right, so y sub 1 equal to y naught plus h f of x naught y naught, right? Okay, so there will be y naught given, which is 1, right? So note x naught, y naught equal to 0, 1. So we have 1 plus h, which is 0.1. And f of x naught, y naught, right? So we have, look, x to the third power, 0 to the, so everything is 0, right? Minus 2y is 1. Make sense? Note f of x sum naught, y naught. Yeah, we don't have to do not. I mean sub. Crazy right now. So x sub 3 e to the negative 2x minus 2y, right? So we plug in when x not equal to 0, 1 equal to y naught, right? All right. So that will be, can you please calculate? 1 plus 0.1 minus 2, which is 0.8. Okay, that will be x sub 1, y sub 1, which is equal to 0.1 and y sub 1, which is 0.8, right? Because x sub 1 is given here, right? X sub 1, 0.1, x sub 2, 0.2 there, right? X sub 3 is 0.3. Clear? Okay. All right. Next. So y sub 2 equal to y sub 1 plus h f of x sub 1, y sub 1, right? Equal to y sub 1 from the previously, we have a 0.8 and plus the step size is 0.1 and f of, let's see, x sub 1 is 0.1, so 0.1 to the third power e to the negative 2.1 minus 2 y sub 1, which is 0.8, right? Make sense? Do you understand what we are doing, right? Okay, now, can you please calculate everything? So we get 0.64. All right, let me add the page here. No, not this one. Okay, so then we get x sub 2, y sub 2, which is x sub 2, 0.2, and y sub 2, 0.64. Yeah. So 0.2 and 0.64. Okay, now the last one. So we have y sub 3 equal to y sub 2 plus step size f of x sub 2, y sub 2, right? Equal to y sub 2 from previous 0.64, 4. So 0.64, step size 0.1, then f of x sub 2. Okay, so we have x sub 2. X sub 2 is 0.2 to the third power e to the negative 2.2 minus 2 times y sub 2, which is 0.64. Okay, now can you please calculate? This will be 0.5126. So x of 1, I'm sorry, x of 3, y sub 3, x of 3 will be 0.3, right? And y sub 3 will be 0.5126. All right? Okay, so this is how we find. So x sub 1, y sub 1 there, x sub 2, y sub 2 there, x sub 3, y sub 3 there. Yeah. So we make approximate values for the solution with the initial value y over 0 equal to 1 with that differential equation with the step size 0.1. Yeah, make sense? Okay, so let us do second one. Second one we have find y of 0.2. That means this is x, right? Yeah. When x equal to 0.2, what's the y value, basically, right? And then the step size will be 0.05 with the initial value y of 0 equal to 1, same as earlier, right? And 2y, let me see, is it same? Yeah, looks like the same question, yeah? I see. Looks familiar. So yeah, it is the same question, yeah? But then the step size is different. It was earlier 0.1, but now 0.05. So 0.05, then the beginning, we start at 0, and x of 1 equal to 0.05. We add 0.05, which is 1. We add 0.05, 0.15. We add 0.05, which is 0.2. So x equal to 0.2, then we can start. Yeah. So we have 1, 2, 3, 4, 5. All right. So let's do that. And then they say that we need to compare the approximate values with the exact solution. Yeah. Why are we doing Euler method? Because we cannot find the solution, right? That's why we are doing the Euler method, right? So in that case, we cannot notice the exact solution, original solution, right? But then in that case, it's a given, so we can compare how much the approximation is close to actual solution, right? Okay, so let's do it. Uh, the solution, I mean the formula, let me use it. Copy. Okay, let's do it. So it's 0, we don't have to do, so y sub 1? Yeah, ridiculous writing out. So start to that. So y sub 1 equal to y naught plus the step size and x, the function x naught, y naught, right? Okay. Y naught? So y naught equal to 1? Because we had initial x naught, y naught, which is 0 and 1, right? Yeah. Yeah. Writing out. Back. All right. So um, x not, y not, 0, 1. Yeah. Okay. So y naught, which is 1 plus step size is 0.05. And then the function, do again. Uh, x not equal to 0, y not equal to 1. The function, oh, I need the function. Where are you? We have, hold on 1 second, let me find out. Okay, so I can find the function here, right? Okay, so let me just using here, x equal to 0, so we have a 0 minus 2, 1, right? Okay, now can you please calculate? What do we have? It's a 0.9? Okay, so x sub 1, y sub 1 will be then x sub 1, which is 0.05. Y sub 1 will be 0.9, right? Oops, you cannot see. Sorry about that. Yeah. Okay, now y sub 2. So y sub 2, so y sub 2 equal to y sub 1 plus step size f of x sub 1, y sub 1, right? Okay, so y sub 1, which is 0.9 plus h will be 0.05, right? And f of x sub 1, x sub 1 will be x sub 1, 0.05 to the third power e to the minus 2, 0.05 minus 2, y, which is 0.9. Yeah. Okay, now, can you please calculate? 0.81. Good. So we have x sub 2, y sub 2, which is x sub 2 was 0.1. Y sub 2 will be 0.81. All right? Okay, we're gonna stop until 0.2. All right, so let us do a couple more. So y sub 3 equal to y sub 2 plus step size f of x sub 2, y sub 2 equal to y sub 2, which is 0.81, step size 0.05. Now the function x sub 2 is 0.1. So 0.1 to the third power e to the negative 2.1 minus 2, y, which is 0.81, right? All right. Can you please calculate? Okay, 0.70, sorry, 0.7290. All right, so we have x sub 3, y sub 3 equal to, so x sub 3, which is 0.15, y will be 0.7290. All right, okay, the last one. Y sub 4 equal to y sub 3 plus step size f of x sub 3, y sub 3, right? Equal to y sub 3, which is 0.7290 plus step size, and f of x sub 3, which is 0.15. to the third power e to the negative 2.15, negative 2 y sub 3, which is 0.729. Yeah, sorry, a little bit smaller. Yeah, okay. Now, the last one, can you please calculate 0.6562? Okay, so x sub 4, y sub 4, which is x sub 4 will be 0.2, right? So 0.2. And y sub 4 will be 0.6562. Yeah. Okay. The question say that find y sub 0.2, right? So which is x. In that case, x of 4 then, right? So y of 0.2, which is 0.6562, right? So in that case, there will be x of 4, there will be y sub 4. Make sense? Okay. Now they say that we want to compare the approximate values with the exact solutions. So this is original equation, right? Original solution. Okay, let's do that. So I have a nice table here. Yeah. Okay. We had, let me highlight. We had a step size earlier, h equal to 0.05. When x equal to 0.2, then we had a 0.6562, right? Yeah, we found just now, right? Okay, let's find out how much we did that closely with the original exact solution. Compare with Euler method to find the estimation, right? Approximation. All right, let's do it. Okay, so we had x naught equal to 0, x sub 1 equal to 0.05. Step size, let me bring this one here. Copy. All right, so we just plug in. Yeah, so let's do it. Why not? So x not equal to 0, y not equal to e to the negative 2, 0 over 4, 0 plus 4. Okay, so e to the 0 power is 1, right? And then we have 4 and 4 is simplify, which is 1, right? Okay, when x of 1 equal to 1, sorry, 0.05. Where did I get the 1? 0.05. Y sub 1, which is e to the negative 2, 0.05 over 4, x 0.05 to the fourth power plus 4. All right. Can you please calculate? Which is 0.90, same as 0.9, right? Okay, I need more. Yeah, let me take out this one here. All right, so x sub 2 equal to 0.1, right? X sub 2 equal to 0.1. Sorry, 0.1. I said the 0.1 and then I put the 0.2. 0.1. So y sub 2 equal to e to the negative 2, 0.1 over 4, and 0.1 to the fourth power plus 4. Can you please calculate? 0.81. Very good. Okay, so two more. So x sub 3 equal to 0.15, y sub 3 equal to e to the negative 2, 0.15 over 4.15 to the fourth power plus 4. What do you get? 0.74? Okay, last one. X sub 4 equal to 0.2, y sub 3 equal to e to the negative 2, 0.2 over 4, and 0.2 to the fourth power plus 4. What do you get? Points, oh, no, not 0.74, 0.67? Okay, let's compare. So when x equal to, yeah, sorry, it's hard to see, right? So we had a step size 0.05. When x equal to 0, it's 1, yeah? 0.81, 0.9. When x equal to 1, sorry, it's a 0.9 for the original one. Euler is 0.81, right? X sub 2. No, wait a minute. This is not the right one, right? Because uh, I was using, this one is 0.05, right? So uh, 0.05. Yeah. So let me just hold on 1 second. Where is the, this is 0.05, right? And then I just compare 0.2. Now we had a 0.6562 earlier, right? So 0.6563 actually there, right? Okay, let's compare only that. So we have 0.05, which is 0.9, 0.1. There's 0.81. Yeah, right? And then 0.15. Yeah, we don't have that. So 0.2, right? So 0.67. So 0.2, 0.67. Yeah. Okay. So this is exact solution from this one. So it's not much difference, very similar, right? So we understand this section? All right, so thank you for watching, and this is the solution, the integral graph. Yeah. So directional field, integral curve. I said, right? Integral curve. Yeah. Okay. Thank you. Bye. We'll see you in the next video.